Ever wonder why airplanes sometimes paint thick white lines across the sky? Some flights leave a streak that lingers for hours. Other flights pass by and leave absolutely nothing behind. It looks almost like the plane is leaking, or that the engine is puffing out a long ribbon of smoke. This is a real puzzle that anyone who has looked up has noticed. The sky can be full of stripes one day and completely clear the next. What could make a 400-ton machine draw clouds in midair? Let's pull this apart one drawing at a time. By the end, you will be able to read the sky like a forecast. Most people assume the trail is a kind of smoke, like the exhaust pipe of a dirty old car on the highway. It looks like burning fuel leaving behind gray particles. This intuition is reasonable, but it is also wrong. Jet fuel is a kerosene-based liquid that burns very cleanly. The exhaust is mostly invisible carbon dioxide and water vapor. You cannot see water vapor with the naked eye. So the white line cannot be a stream of gas itself. The line is a side effect, not a waste product. To see why, we need to look at what the air is doing up there. Jet engines work by burning fuel in a controlled chamber. The combustion reaction consumes oxygen from the air. Hydrogen atoms inside the fuel combine with that oxygen. The chemical product of that combination is water. The hot water leaves the engine as a vapor, which is just water in gas form. Every kilogram of fuel produces about 1.5 kilograms of water. A large jet engine can release hundreds of liters of water per second. All of that water leaves the tailpipe as an invisible gas. So the engine is essentially a giant humidifier in the sky. That is the first ingredient of our trail. Commercial jets cruise at around 10 kilometers up. That altitude is roughly the height of Mount Everest. Air pressure at this height is much lower than at the ground. Lower pressure means fewer air molecules packed into a given space. With fewer molecules, the air cannot hold much heat. So the temperature at cruising altitude is extremely cold. On a standard day, it sits around -56 degrees Celsius. That is colder than any natural temperature on Earth's surface. The air up there is so cold that a glass of water would flash freeze. Now we have a hot, humid exhaust meeting a deep freeze. When hot, moist air meets very cold air, the water vapor does two things. First, it cools down below its condensation point. Condensation is the moment a gas turns into liquid water. You see this when a cold soda can sweats on a hot day. The water vapor in the air cools against the can and becomes drops. In the jet trail, the vapor cools against the freezing air behind the plane. Tiny liquid droplets form in a thin sheet behind the engines. But this high up, those drops do not stay liquid for long. The surrounding air is well below the freezing point of water. So the drops almost instantly freeze into solid ice crystals. This second step, when a solid forms from a gas without becoming a liquid first, is called sublimation. Wait, let me restate that. Sublimation is when a gas turns directly into a solid, skipping the liquid stage. You have seen sublimation in cold freezers when ice cubes shrink over time. The ice disappears into the air without ever melting into water. In our contrail, the water vapor does a similar trick in reverse. It goes from a gas straight to tiny ice crystals. These crystals are about the same size as the droplets in a thin cloud. Billions of them cluster together behind the plane. Together they scatter sunlight and appear white to our eyes. That visible white line is what we call a contrail. Contrail is short for condensation trail. It is an artificial cloud made by an airplane. It belongs to the same family as natural cirrus clouds. Cirrus clouds are the high, thin, wispy sheets you see on clear days. Now here is the interesting part. Some contrails vanish in seconds. Others spread and linger for hours. The difference comes down to humidity at that altitude. Humidity is just a measure of how much water vapor the air already holds. If the surrounding air is dry, the ice crystals quickly sublimate back into vapor. Sublimation works both ways, gas to solid and solid to gas. The trail simply evaporates and disappears. If the surrounding air is already humid, the crystals can survive. They may even grow by pulling more vapor from the air. A persistent contrail tells you the high atmosphere is near saturation. Saturation means the air cannot hold any more vapor at that temperature. Meteorologists call this the saturation point. At that point, any extra vapor will condense or freeze. So a long-lasting trail is a humidity flag in the sky. Pilots and forecasters use this as a real piece of data. If a trail spreads into a sheet, the upper air is very moist. If it cuts off quickly, the upper air is dry. The contrail is effectively a free atmospheric sensor. Let us look at 3 common cases pilots describe. Type 1 is called a short-lived contrail. It forms right behind the engines and fades within a few seconds. This happens when the upper air is too dry to sustain ice. Type 2 is a persistent contrail. It stays as a thin line and may stretch for many kilometers. Type 3 is a spreading contrail. It widens and turns into a thin sheet of cloud. Spreading contrails are the most common type of artificial cirrus. They can cover large areas of sky and last for hours. All 3 are made of the same ice crystals. The only difference is the humidity of the surrounding air. Humidity controls how long the ice can stay frozen. Temperature controls whether the ice can form at all. Together they decide the entire life of a contrail. The plane is just a trigger. So let us put the full chain in order. Step 1. Jet fuel burns and creates hot water vapor. Step 2. The vapor leaves the engine and meets freezing air. Step 3. The vapor sublimates directly into ice crystals. Step 4. Humidity decides if the crystals survive or vanish. Now let's see why engineers care about this. Airlines and aerospace researchers track contrails carefully. Persistent spreading contrails can affect the Earth's energy budget. They trap outgoing heat from the surface like a blanket. At the same time, they also reflect some sunlight back into space. The net effect is a small but real warming contribution. Climate scientists include contrails in their models. Flight path planning can adjust altitude to avoid humid layers. Flying slightly lower or higher can sometimes prevent contrail formation. This saves fuel impact on the climate per flight. Airlines already use contrail forecast tools for this. Ground crews also study contrails to test engine emissions. Each engine model produces slightly different amounts of water vapor. Engineers use that data to design cleaner future engines. What was once a curiosity is now a climate input variable. Let's recap the whole story in plain terms. Jet engines exhale hot water vapor into the sky. The sky up there is so cold that the vapor freezes into ice. Billions of tiny ice crystals form a white line behind the plane. That line is called a contrail, short for condensation trail. It is a man-made cirrus cloud, not smoke. If the upper air is dry, the trail vanishes in seconds. If the upper air is humid, the trail can linger and spread. So a contrail is both a cloud and a humidity sensor. The same physics explains your breath on a cold morning and the frost on a frozen window in winter. Next time you look up, watch the trails carefully. You will know exactly what the atmosphere is doing at that height. That is the mechanics behind every white line in the sky. And that is how physics turns fuel into a temporary cloud. Thank you for watching this video. Let me know in the comments if you liked it. Don't forget to like and subscribe for more.